Welcome back. This is Thermodynamics II homework solutions from South Dakota School of Mines and Technology. This is homework 6, problem number 1. Okay. It says, assume component 1 and component 2 of a mixture form an azeotrope. So as soon as I see the word azeotrope, in my brain it should click at an azeotrope that yi is equal to xi. Okay? Before I do anything, I should just recognize that. Okay, it's saying that x1, which is equal to y1, is equal to 0.4 at the azeotrope. Okay? Saying that T is equal to 350. Okay. Saying the P of the azeotrope is equal to 75 kPa. Saying that P1 sat is equal to 70 kPa. P2 sat is equal to 65 kPa. It's also asking what's the bubble pressure. Okay. At x1 equals 0.75, what's the bubble pressure? Okay. And we're going to assume that the Porter model or the two-suffix Margulis model applies. Okay, so we have really two problems here. We have the azeotropic component, and then we have just the normal bubble pressure component. Okay, so let's tackle the azeotropic component first. Okay, so I've already recognized that at an azeotrope, yi equals xi. Okay. If you want to be more explicit, well, you can put these things right there. Okay. Now, well, I always need to write down my equation. So my main equation here, always is yip equals xi gamma I pi sat. I got Raoult solve for adults. For those of you who are not, from South Dakota School of Mines and Technology, this one's Raoult solve for adults. We also have Raoult solve for PhDs. We also have Raoult solve for kids. Raoult solve for PhDs has all the fugacity coefficients and point correction factors. Raoult solve for kids assumes an ideal solution. Okay, so this one is a Raoult solve for adults. Okay, so I'm a Raoult solve for adults, but I'm at an azeotrope, and so because those equal each other, they cancel each other out. Okay, and so as a result, I have P equals gamma I pi sat, which is equal to gamma 1 P1 sat, which is also equal to gamma 2 P2 sat. Now, why are they all equal to each other? Well, because the pressure is consistent. Why is the pressure consistent? Because I'm at equilibrium. These are vapor-liquid equilibrium problems. I'm at equilibrium. That means I have to be at mechanical, thermal, and chemical equilibrium simultaneously. Okay. And so I need all three. Okay. Now, so I have that. All right. And really I want to focus on this one. Okay. Now, can I do this problem with P equals gamma 1 P1 sat? Technically, yes, but I'll actually get a different result because of the model I'm using. Because I'm using two-suffix Margulis, I'm overdefined. I have two equations, one unknown. Okay, and so I'm overdefined. Okay, and so really, the core that's problematic is this azeotrope is probably not at 75 kPa. And if I do this route, I don't need to know where the azeotrope is. Really, I should take that out of the problem. Okay. Yeah, I'm thinking I would do that. But in any case, I want to focus on these ones. Okay. And so what do I want to do is I got that, and now I want to kind of separate them, and rearrange this. So I want it to be P2 sat all over P1 sat. This is equal to gamma 1 over gamma 2. Okay. Well, shouldn't it be gamma 2 over gamma 1? No, because I'm bringing this one over here and I'm bringing this one over here. Okay. Now, I can keep it that way, but I want to put RT natural log on both sides so I can utilize what I know about the Porter model, which says RT natural log of gamma 1 is equal to AX2 squared. RT natural log of gamma 2 equals AX1 squared. And some of you out there in the interwebs might be like, oh, that's not the 2 suffix Margulis, that's not the Porter model. There is no RT. It depends upon who you ask. We're using Koretsky's thermodynamics book, and this is how it's done in Koretsky. Other books like Smith and Van Ness and Abbott, I'm not sure who else, they're going to absorb the RTs into the A's. But we're keeping it separate. We're keeping A as a truly constant here, just not unitless. Okay. So in any case, so we want to have RT natural log. If that's not how your book does it, if it's natural log, then you would just leave it as natural log on both sides. The point is we want it so that we can just kind of plug things in, so that we can use natural log rules. RT natural log of gamma 1 minus RT natural log of gamma 2, and then I can plug things in. So this AX2 squared minus AX1 squared. Okay. And so I plug that in. Okay. And then, I know P2 set, I know P1 set, so that's, and I know R and I know T, so that's kind of just a constant. Okay. So, we can just say, okay, this equals kappa 1. Okay. And so kappa 1 is equal to A, and I pull out my like term, so I have AX2 squared minus X1 squared. Well, I know X2 at the azeotrope, because I know X1 at the azeotrope. It's 0.4, so X2 is 0.6. And so when I'm all said and done, I have kappa 1 over X2 squared minus X1 squared is equal to A. Okay. And at this point, I just plug and chug. Okay. And so now that I have A, that's the first part of the problem. The second part of the problem is doing the bubble pressure. Okay, so the bubble pressure. Well, with the bubble pressure, again, I write down all my equations, okay? Man, okay. So I can have my algorithms in mind, but really at the core of these problems, I want to think about whether I'm doing bubble pressure, bubble temperature, dew temperature, flash, phi. It doesn't matter. It all boils down to what are my equations, what do I know, what do I don't know, and what do I have value for? Okay. And so my equations in this case are yip equals xi gamma I pi sat, which is what? That's right, that's Raoult's law for adults. So if that's so that's going to be the main equation, at least in this case. What's the other main equations I'm going to use? I'm going to use summation of xi equals 1 or summation of yi equals 1. I might use both, but for the most part I'm going to use one or the other. I'm going to use the one that I don't already know adds up to 1. Now I'm given x, and so I already know that 0.4 plus 0.75 plus 0.25 equals 1. So this one's not the one I'm going to want to use. I'm going to want to use that one. All right. And so what I'm trying to do is I got 3 equations, 3 unknowns. I only count 2. Well, I have 1 for each component. Okay, so I have 2 Raoult's law for adults and 1 summation. Okay. Now I could approach this problem in many different ways. Okay. But how I want to approach this problem clean this. How I want to approach this problem is I want to keep in mind what do I know, what do I don't know, and what do I have a value for. So I know, well, it's a bubble pressure, so I know temperature and I know x. And that's what's given, obviously. As a result, I also know Psat, and I also know gamma i's. What I don't know the bubble, and I don't know the pressure. Do I know anything else as a result? No, I know everything else, so just because I don't know yi and I don't know p, but there's nothing else I don't know because I don't know those two. Okay. And so, I know that guy, I know that guy, I know that guy, I don't know those two guys. Okay. So what am I trying to do? Well, I know now. I know that I know and I don't know. I'm trying to get values for everything. Okay, and again, I have two equations, two unknowns. Okay, so I have this equation, which is y1 plus y2 plus y3 plus forever how many components I have. Okay, and but all my yi's are in here. Every yi is going to be kind of related to this thing. So I want to solve it for yi first. Yi is equal to xi p gamma I pi sat all over p. Okay? I've just basically I've reduced Raoult's law for adults for each component into y. Okay, in one fell swoop. And now I can combine, quote unquote, those two equations into my into my third equation, which is this guy. Okay, so summation of xi gamma I pi sat all over p is equal to 1. Okay. Now, but before I do that, again, so I don't get lost in the logic. So let's back up a little bit. Okay, I solve for yi. And I ask myself, okay, I don't know yi, do I know everything else on the other side? Okay, let me ask that. Do I know xi? I do know xi. Do I know gamma I? I do know gamma I. Do I know pi sat? I do know pi sat. Do I know p? Nope, that's in my don't know column. Okay, and so everything that's on quote unquote the right side of the equation I don't know. Okay, so I need another equation. The other equation is the summation. So I plug it into here, okay? And again, I want to put everything I don't know on one side and everything I know on the other side, okay? And so I said I didn't know p, so I want to move that over. Well, everything's divided by p, so I can multiply both sides by p and get p is equal to summation of xi gamma I pi sat. So I don't know p, but do I know xi's? Yes, I do. Do I know gamma i's? Or have a value for it? Yes, I do. Do I know or have a value for pi sat? Yes, I do. So I know or have value for everything on this side. You might be like, what do you mean have a value for? Well, if I have a value for it, I can at least get a number for p. And so in any iterative process that I have, if the degrees of freedom do balance out, okay, that, I can get, this number, and I can use that to update numbers I don't know. In this case, that I don't need to do that, but in some cases I do. Like, let's say I had, Poynting correction factor. Let's say I had fugacity coefficients. Let's say I had all that nonsense, okay. I would have to use that to update. I'd get a p, and then I'd use p to update all my fees, okay, and so on and so forth. Okay, now, but I know all those, so I can just plug and chug. Because I know gamma I, because now I know A, because I got it from the azeotrope. I know pi sat, because it was given. I know xi, because it was given. And I plug and chug, and I get a p. Okay, so now, I can say I have a value for p, but really I have p, so I could put a check mark there. But I'm just going to put a little x. Okay, but I look back at my little grid, okay, know it, have value for it. Do I have, or no, I have value for yi? No, I don't. Do I have an equation for yi? Yes, I do. And so I go back to the equation. Do I know I have a value for xi? Yes, I do. Do I know I have a value for gamma I? Yes, I do. Do I know I have a value for pi sat? Yes, I do. Do I know I have a value for p? Yes, I do. Do I have enough information to get yi? Yes, I do. And so I do that for each yi. And what am I trying to find? Well, I'm trying to find yi and trying to find p. How do I know that's what I'm trying to find? Well, it says the bubble pressure. Okay, and so that's going to tell me what the bubble pressure is.